In this section, we're going to be focused on how to factor polynomial functions. As we can see, we've got quite an extensive list of topics, so a number of different factoring techniques that we're going to look at for different situations. The first one is factoring a difference of squares, which is, or at least tends to be, in my opinion, the easiest factoring technique. It's pretty easy to pick up on. What we're looking for is something of the form a squared minus b squared, meaning we have exactly two terms, the second one being subtracted from the first, and each of those terms need to be perfect squares. If so, we can factor this as a minus b times a plus b. Looking at a few examples, we'll see how we can rewrite each of these given expressions as that difference of squares, identifying both the first and second terms as perfect squares, and then apply this method. To start off, we can rewrite in example 1 that first term, x, as that quantity x raised to the second power, and then 16 can be rewritten as 4, that quantity raised to the second power. So since both the first and second terms are perfect squares, we can go ahead and apply this approach and factor this as the quantity x minus 4 times the quantity x plus 4. In example 2, we have a case where our first term is slightly more complicated, but we can still express that as a perfect square. In this case, this would be the quantity 4x squared and then 9 would be the quantity 3 squared. So that means that we can factor this using difference of squares and rewrite it as the quantity 4x minus 3 times the quantity 4x plus 3. Example 3 is similar. What we have is 25x squared minus 64. So this can be rewritten as the quantity 5x squared minus 8 squared. Since we can rewrite each term as a perfect square, that means we can go ahead and factor this as 5x minus 8 times the quantity 5x plus 8. We don't really need to show these intermediate steps where we rewrite both the first and second terms as some quantity squared. However, if you're not as comfortable with this approach, or if it helps you to see that pattern and how difference of squares would apply, absolutely feel free to take advantage of that.